You throw a 10 kilogram pumpkin with a velocity of 1 meter per second at your friend who is standing on a stationary skateboard. He catches the pumpkin and begins to roll away. The mass of your friend plus his skateboard is 70 kilograms. What is your friend's speed after he catches the pumpkin? Okay, so to solve this problem, we need to know two things. The law of conservation of momentum, which tells us that system momentum before a given event is equal to system momentum after that event. And we need to know that momentum can be calculated by taking the product of mass and velocity. So initially, this system has momentum due to the pumpkin. So the skateboarder isn't moving, so the initial system momentum comes from the pumpkin. So it'll be the mass of the pumpkin, 10 kilograms, times the velocity of the pumpkin, 1 meter per second. This is going to be equal to the system momentum after the two become coupled. So after the two become coupled, they have a combined mass and a shared velocity. So their combined mass will be the 10 kilograms of the pumpkin plus the 70 kilograms of the skateboarder and skateboard times their shared velocity, which we'll just label v with a subscript f. Now if we solve for this shared velocity by dividing both sides by this value, which is 80 kilograms, we end up with final velocity equals 10 kilograms times 1 meter per second, which is 10 kilogram meters per second divided by 80 kilograms. Kilogram units cancel. We have 10 over 80, which gives us 0.125 meters per second. And this is positive because the direction of motion of the skateboarder and the pumpkin is the same as the direction of motion of the pumpkin initially. In any case, we're just looking for the speed here, so 0.125 meters per second is perfectly acceptable without an associated direction.